Hi there, welcome to this screencast about the effect of a knotted network on IP tables when we create it via libvirt. So what are we going to do in this screencast? First, we are going to determine the IP tables commands done by libvirt when a virtual network is started. So when the default network is defined and it is started at boot time by libvirt, what are the exact IP tables rules that are done by libvirt? Okay, so what are we going to do? First of all, we are going to examine the situation where we don't have a default network. Next, we are going to create an isolated network. The default network is going to be an isolated network, and we are going to examine what rules are added to IP tables. The third situation we are going to create is a knotted default network, and again we are going to examine the impact on the IP table rules. And of course we are going to show the differences to understand what is actually happening. Okay, just to be sure why we want to understand this, well, when we do a ping command from this router, which is a Fedora 23 router, from the default network which is knotted, we are able via the host, a couple of other home networks, to reach the internet to google.nl. So why does it work when libvirt is creating this default network? So what is done with respect to knotting and what is done with respect to IP table rules? Hi there, in this screencast we are going to analyze the differences between the different network types that can be added via libvirt. We are going to examine the filter table, specifically the forward chain, and the not table, the post routing chain. The first situation that we are going to examine is that we have no default network. The second situation, we will create an isolated default network, and in the third situation we will create a knotted default network. So let's first start with creating the situation where we have no default network. If we have a default network, we are going to destroy it and we are going to undefine it. So now the default network is gone. At this point we want to measure the forward chain of the standard filter table, and we want to measure the not table, specifically the post routing chain. We store the information in the filter and the not files. Now we want to demonstrate that there is no default network. We will use the virsh netlist command. And the -all means that it will also show the defined networks even if these are not active. Okay, the next thing that we are going to do is that we're going to create an isolated default network. So how does our isolated default network look like? Well, we have a definition file, and what is important here is that we don't have a forward element with type not. So basically the name of the network is default. We will define a virtual bridge 0 interface. This is the MAC address and it will have an IP address. Okay, so let's create this one. First we define it and then we will start it. We are successful. So now we are going to capture again the different chains in the different tables. So in this case we are going to capture the forward chain in the filter table and we place it in the file isolated filter, and over here we are going to capture the post routing chain in the not table and we are going to put it in the isolated not file. Okay, so let's see. We have over here we got the default network and it's active. No means it's not auto starting. Okay, so at this point we are going to create the knotted version of the default network. So let's first examine what it looks like. And here one can see that the definition is more elaborate, and in this case we do have the forward element and it has got a not mode. In the not mode we can also specify the port range, which we do. Okay, originally when we installed our system, and installed the libvirt RPM packages, this default network also starts up a DHCP server with this range. So we're going to create exactly the original default network definition. Okay, so first we destroy the default network as it was, we undefine it, then we define it based on the not default, and then we're going to start it. Let's execute all these commands. Everything is successful. So now we are going to capture again the different chains. So now we are going to capture the chain and we put it in the not filter file. Next, we are going to capture the post routing, and we are going to demonstrate that again the default network is active. Okay, so now we basically got our 6 files of basically three different situations of the default network. One when it is not existing, one when it is an isolated network, and the third one when it's a NATted network. So let's examine the differences between these. So over here we show the vim commands, and the first one that we are going to use, we are going to examine the difference between the non-existing default network and the isolated default network, and we are going to examine the filter table, the forward chain. Okay, let's increase the terminal size in order to make it nicer viewable. On the top we got the situation in which we don't have a default network. We can see we have 19 rules in the forward chain, and well, basically we don't see the virtual bridge interface in it at all, and we don't see anything related to the IP address 192.168.122. When we added the isolated network, we see that we have now 22 IP table rules, and when we look at the difference, we can see that we have 3 extra rules. Rule 1, 2 and 3. So basically what does this say? All traffic coming in from the virtual bridge network interface and what is going out via the virtual bridge network interface with source any and destination any is going to be accepted. All other traffic that involves going out via the virtual bridge interface and coming in via and going to any other network device is being rejected. So rule 2 and rule 3 reject all the traffic. So basically what it means is that all the systems that are located in the default network can reach each other via the host system. Okay, so that's the difference between no default network and the isolated network, with the impact on the filter table, the forward chain, and with the impact on the post routing chain of the NAT table. When we analyze the effect on the NAT table, we will see that they are basically equal. So there's no impact on the NAT table when we use an isolated network. Okay, so what is the impact when we start using a NATted default network? Well, let's see the difference between the isolated one and the NATted one. Again, we are going to change the terminal to full screen, and in the isolated filter we had 22 rules, and now in the NAT situation we have 24 rules. Again, when we analyze what is going on, we see our 3 rules And basically in the second situation we also see the similar 3 rules over here, but this time we see 2 extra rules, rule number 1 and 2. And what do these mean? Well, all traffic going out via the virtual bridge interface, coming from anywhere with destination, this is the IP range of the default network. If it is in connection tracking state related established, then it will be accepted. So this is returning traffic, and the originating traffic is the one that is coming in via the virtual bridge interface that is going out to any interface coming from the default network IP range to anywhere, and this one is going to be accepted. So basically what it means that all traffic coming from the default network and going out towards the internet, for example, is going to be accepted. So this is the impact of having a forward type of NAT defined by libvirt on iptables when we examine the forward chain of the filter table. So actually these 2 rules make it possible to have network traffic going out to the internet routed via the host. Okay, then we still have to figure out what the impact is of the forward type NAT on the post routing chain of the NAT table, and we can see from here clearly there is a difference. We have 3 rules versus 8 rules, so we got 5 extra. And the first 3 are similar to these 3. So clearly the first 5 have been added by libvirt. So what does it say? Well, basically we got the return target, and here another return target. This is traffic coming from the default network IP range going to multicast addresses, and this traffic is returned. Same goes for traffic coming from the default network going to the generic broadcast address, is also returned. The interesting part is over here with the masquerade target. Basically, if we start with the lowest one, all protocols coming in from any interface going out through any interface, coming in from the default network range going to somewhere else, is going to be masqueraded. Masqueraded means that the host will pick up the traffic and it will send it out via its own IP address, keeping track of the connection state. The same goes for protocol traffic that is UDP or TCP. Basically the rules are the same, only in this case you can say we will start using the masquerade ports 1024 to 65,535. This makes it possible to go out to the internet when the traffic is originated from the default network. Okay, in the screencast we have seen what rules are in iptables when we don't have a default network. Next we analyzed the isolated default network. We saw that libvirt adds 3 filter rules and no NAT rules. Finally we analyzed the NATted situation, and then we saw that libvirt added 2 plus 3 filter rules. So the same 3 from the isolated network and 2 extra in order to route traffic coming to and coming from and going to the default network, and it added 5 NAT rules. Okay, thanks for your attention. Next we are going to manually configure the NAT rules starting from an isolated network to figure out if we can actually make it work by hand. In the description below I've put links to relevant pages, and I also put in the comments that were used in this screencast. Hope you enjoyed it, and you can subscribe to my channel to get more information.